Hey, good morning, everybody. Hope you guys are doing well. We've got 11, about to be 11:59. I'm gonna give it a couple more minutes. Let people keep rolling in. Hope everybody's having a good week this week. Happy almost Friday. All right, so I've got 12 o'clock on the dot. Still gonna give it. We still got people coming in, so I'm gonna still give it about another minute, maybe 2 minutes. Another minute and a half. We'll get started here again. Yeah, thanks to everybody showing up, coming in, especially those of you on the East Coast joining in on your lunch break. Appreciate it. Hope everybody's having a good week so far. I'll go ahead and apologize in advance for any coughing and excessive throat clearing. I live in East Tennessee, and we have been dealing with air quality issues with some of the Canadian wildfire smoke. So it's been doing a number on a lot of us down here the last couple days. All right, I've got 12:01. I'm gonna give it about another 30, 45 seconds, and we'll get going. Still seeing people coming in. Again, hope everybody's having a good day, having a good week. It's almost Friday. We're almost there. You've almost made it. All right. Now it's almost 12:02, so we will go ahead and get started. So yeah, welcome everybody. My name's Tim Buffkin. I'm the National Sales Manager of Broadband here at NCAV America. Welcome everybody. Thank you for joining our latest series of monthly webinars. Today we're going to essentially doing a refresher, if you will, on our air jetted cables technology, right? Blowing cables, micro cables. So we'll be going and talking a lot about that type of technology and those types of cables today. So again, welcome, and we'll get going. So this webinar, just like all of our others, are RCEP compliant. So that means that you can register, and you can take a quiz that will follow this test to get continuing education credits. So again, at the end of the presentation, I'll give you some more details about that. But just let you know, if you are interested in continuing education credits, we do comply with that. So again, what are we going to talk about today? Essentially, we're going to be talking about get an understanding of call it the basic understanding of a blown cable network, right? What does that cable look like? What's the importance of product selection in this type of networks? What are the benefits that go along with it? But then we're also going to talk about being able to explain the difference in the footprint of what a blown cable network looks like, and then also talk about why it's beneficial, right? Why do we want to look at a network using micro cable, micro duct type technology? So the agenda, introduction again, Tim Buffkin. We went over the learning objectives and the continuing education credits. Then we'll have a presentation at the end. You can use the chat feature to ask any questions. If you have any questions during the presentation, you can go and put them into the chat, and I'll go back and revisit them at the end. We do just ask that you keep questions pertaining to this presentation. If you have any business particulars you want to discuss, we can certainly do that afterwards. So that said, let's begin. So, blowing technology, right? If we hear people talk about blowing fiber, or also you can hear called jetting. Essentially, what we're doing here is we are floating a cable down a conduit. Obviously, traditionally through conduit, you usually pull the cable, but this you're actually going to start at the front end of the duct, and we're going to push the cable through it. It's awesome to be able to cover long distances, and we're talking thousands of feet, right? So we're going to increase the amount of distance that we can travel. So what we can do with that is, essentially create fewer splice points that are needed, but also drop down the amount of handholds that may be needed, right? Of course, your particular build may be different if you're doing a fiber to the home build, right? Then the amount of handholds may not necessarily get affected as much. But if you've got a long haul network or a backbone route that you're trying to go and you essentially cover from point A to point B and go 100 miles, 200 miles plus, whatever it may be, you can really cut down on the material and labor costs from that standpoint. Then again, too, when you're doing this, you need fewer crew members, right? So again, like any fiber project, the material is only going to make up 15% of your overall cost. The rest is going to be labor costs. So with blowing technology, we can actually decrease the amount of the people that you're going to need on the job site to get this done, which again is another cost savings. This method, this type of cable, it is something that's very new in the US. If you go over to Europe, this is almost standard practice over there, right? Installing these types of cable. And they've been doing it for a long time. So just because it is a newer, call it a newer trend, a newer technology, getting people that are qualified to do this and do this correctly and do this efficiently, that manpower, I guess you could say that, that market is still growing from a technician standpoint, but it is gaining a lot of traction. So when we look at building an infrastructure this way, again, I mentioned the fast deployment. So we're talking about being able to install cable at 100, almost 200 feet per minute, right? Which is blazing fast when you compare it to just being able to pull cable through conduit. So again, right, and I'll probably repeat myself 100 times. It's all about speed of deployment and cutting time. So obviously at 200 feet per minute, that's exactly what we're doing. The other great thing about this is we're optimizing the footprint of the infrastructure itself. So within the exact same cable, and I'll go into some more specific details on it, but we're increasing our fiber count, but decreasing the size of the cable, decreasing the size of the conduit, decreasing the size of the splice enclosure, right? So we're shrinking the amount of space needed for the entire network. And again, right, when we start talking about doing that, we're also talking about the economic benefits of it, reducing our costs, reducing logistics, right? Freight on the cable, freight on the vaults. We're cutting down on labor. We're cutting down on time, right? This is a solution that's going to lower cost across the board on your project. So when we talk about just the basic principles of blowing cable, right, what we're talking about is we're going to have an initial force setup that's going to push cable through the duct again. So again, our starting point is the front of the conduit. So we're going to push the cable in the first few feet, but then from there, we're going to ramp up the air pressure that's going to blow through the conduit. And then eventually what's going to happen is we're going to create a drag on the cable, and that's going to actually float the cable in the middle of the conduit. So where you're actually getting very little contact between the cable and the duct. Of course, when you're pulling conduit or when you're pulling cable through conduit, you're always dragging on the duct itself, right? So we're creating friction there. So in this case, though, we're creating enough drag on the cable and we're essentially floating the cable in the conduit that we're greatly cutting down the amount of friction in between the cable and the duct itself, right? So you're going to kind of catch a middle point where both forces push against each other, and then from there, it's you're setting sail. The cable's just is shooting down the duct at a very high speed. So we can go about this a couple different ways, and right, a lot of this is going to depend on what exactly you're trying to accomplish, how far you're trying to go. You know, typically what you're going to see for the most part, you're going to do a single length cable blowing. So you're going to have your reel of cable, you're going to have your jetting machine, and then you're going to shoot it from one end to the other. Right now, you might have pedestals in between that you're going to loop through, or whatever it may be. But essentially, it's hey, we have a distance we're going to go. We need to go from point A to point B. That's going to be your single length cable blowing. The really neat thing with this technology, though, is you can actually cascade your installation. So let's say you have a 15 or a 20,000 foot reel, and you just want to get again from point A to point B, and you've kind of extended past how far one machine can get you. You can actually set up multiple machines along your route to be able to blow your cable even farther. So we're still kind of almost doing a one-shot deal. We're just using that second blowing machine as as a repeater or an extension on the original. So again, this is really, really handy for those runs where you've really got to cover a long distance. But again, the setup on this may take a little bit longer, but the amount of time it's going to take you to run through that 20,000 feet or 25,000 feet of a single reel is going to be so much faster than traditional pulling through the conduit. So again, we talked about how much farther you can blow the cable. How far can you go? Well, it's really going to depend on quite a few factors. The biggest one is just going to be the route itself, right? Where, how far is the duct going? How many turns do we have? How many bends? How sharp are those turns, right? Or you might hear somebody refer to it as the sweep. If you have a 90-degree bend, how tight is that bend, right? Is your sweep, is it 15 feet? Is it 20 feet? Or is it a lot tighter, right? So those are all things that are essentially going to affect how much contact the cable has with the conduit, which is going to create friction, which then obviously is going to shorten how far you can go. So you could have a tight area with multiple bends, not an ideal fill ratio. And by that, I mean the ratio of the cable diameter to the inner diameter of the duct. We'll touch on that in a little bit as well. So, you could be looking as short as 1,600 feet, right? However, in a normal installation where we're talking about very few bends, a good fill ratio, you can go up to 6,500 feet. And I'd say that's kind of the norm, if you will. You can go farther than that, but again, it's just going to depend on a lot of different factors. I do know that some of the companies that make jetting machines actually have some really cool technology where you can plug in your route in terms of, we're going to go 600 feet this way, and we have a 30-degree bend at a 20-foot sweep. And then we go another X amount of feet, and then we have this bend. And you give them that information, the diameter, right? What type of jacketing you use, and they can almost pretty much down to the exact foot, tell you how far you will go. So again, if you're trying to figure out how far you can go and you're not totally sure, that is a great resource. Use your jetting machine, use the company to help you be a resource to figure out how far you can actually go within your given area. So again, right, the benefits of it, talk about the cable itself. The cables are smaller, they're lighter, they're more flexible. So that means, one, we can get into tighter spaces and situations that you can't get with traditional cable and traditional conduit. If you're in conduit, let's say you've already got some conduit that's been used. If you have enough space to be able to get a micro duct into that conduit, now you've just added to the amount of cable you can fit into even a standard size conduit, right? So you can expand within a given network that's already there. Or again, if you're in a building, let's say, and you're in a very tight area, you have a very limited amount of space to work with. If you can get a micro duct through there, you can install cable through that so much easier. And again, this really just gives you more flexibility on your install, how you can install it, and then too, and how you can expand down the road. The big thing with this, and typically what you're going to see is, if you're going to go the route of micro cable, you're going to use a multi-duct bank. So by that, what I mean is, if instead of just doing a normal, call it a 2-inch SDR11 conduit where you're going to pull one cable through, you can take that that same 2-inch outer diameter, and you can have multiple duct banks inside of there. So now instead of just having one space to fill, you could have 4, 6, 8 different spaces to fill. So you blow your cable through there and you still have extra space, right? So again, right down the road, and I've in some other webinars I've preached the same thing. You always want to, call it plan for the worst. You might have an area where you say, hey, I only need a 48 fiber cable right now. And that may be the case, that may be plenty. But 10 years down the road, 20 years down the road, 30 years down the road, you might get a new industrial complex. You might get a new factory right in your town, and now all of a sudden you need to go back and say, oh wow, we need to do another 144. We need a 288. Well, if you've gone the micro cable route, you've done a multi-duct bank, then you've got potentially 5, 6, 7 other ducts that you can fill. So now instead of having to go back and rebury, you go in your handhole, hook up your jetting machine, blow your new cable in there, and you're done so much faster and so much more cost effective than you would have been had you just, direct buried or just pulled a single cable through a duct. So I can't stress enough how long term, even though the install part will save you money, long term, and the cost savings keep coming back. Right. And again, we talked on the extremely long distances that you can jet it. Again, right, we're potentially dropping the amount of handholds we need, splice enclosures, things like that. So again, right, more labor, more material savings. Right. And then again, from the labor side, if I can cut the amount of time in half, one, I've already dropped the amount of guys that I'm using, but if the amount of time they're going to spend on a job site is now cut in half, I'm saving money there because now they can pack up, they can go to the next location and continue to push this fiber project along. And right, everybody's heard about the BEAD funding that's coming out. You had the RDOF funding. A lot of this funding is tied to being able to get this project done in a certain amount of time, right? Or else you have penalties and things of that nature. So again, if you can get your network installed a lot faster doing this, you're right, there's cost savings, right, that extend beyond just your labor. And again, so I talked about the footprint, right? So if you just look at one, the cable itself, again, the cable is a lot smaller, so you have less material going into it. So you're going to have a natural cost savings there. The conduit, same thing. You can drop down to a smaller conduit, save costs there. Handholds, right? If the difference in being able to put a 288 fiber into a handhole, whereas a standard, call it non-armored cable, you're going to need maybe something like a 30 by 48 volt. But if I can run a micro cable network and I can drop now that 30 by 48 volt, which might cost $1,500, I can drop down to something like a 1730, which may only run $300. But then again, right, the material only makes up part of it. If I'm dropping from a 3048 to a 1730 volt, my labor on that 3048 is probably somewhere around $1,000, if not $1,500, right? So your total cost of ownership of that one vault could be as high as $3,000 for every single vault that goes in the ground. But if I can drop it down to a 17 by 30, now your total cost of ownership may only be, call it $1,000, right? So again, the labor outside of just jetting the cable, you're saving the labor on the vault. And that's where the costs can really add up. And then again, right, the spare duct capacity that gives your company the ability potentially for multiple revenue streams. You get a lot of companies now, they're already leasing out dark fibers, 5G, things like that are going out. And what you're seeing is a lot of these big cell companies, if they don't have to put cable on the ground, they won't. They'll lease whatever they can off of what you have. But now if you've got a 8-path duct bank in the ground, you can go put in a cable specifically for somebody else that wants to do it, or you can just lease out the duct bank, let them install their own cable. But again, it just adds another revenue stream to your company. So, initially when we talk about the setup, it does take a little bit longer on the setup for jetting cable than it does pulling. However, the installation is generally a lot faster. So that difference in the setup is very easily negated by how much faster it goes. Again, touched on, right, the distance and everything. And then we also, again, right, talked about setting up a mid-distance assist blower to be able to go even further. The one very important thing, though, that this does is it puts a lot less strain on the fiber itself, right? So your typical fiber that's going to get pulled through a duct is going to have usually a tensile rating of about 600 pounds. it is possible in installation to go above that and put strain on the fiber, or potentially break the glass inside of the cable, and that could be because of too many bends or what have you, that's creating extra strain or extra friction on the cable. So you can potentially run the risk of damaging when you're pulling. A lot of that goes away when we're jetting the cable in. So again, gives you a little bit more peace of mind with actually keeping everything intact the way it should be long term down the road. So when we're comparing jetting versus pulling, right? So talk about the distance. Typically with pulling, you're talking about 1,000 to 1,500 feet on a single pull, right? Because again, you get up to that point and you potentially risk going above that 600 foot-pound tensile strength and causing damage. Jetting, again, 6,000 feet or more, depending on the route. So we're talking 5 to 6 times the amount of distance you can cover on a single route. And again, with duct, you want to be as straight as possible, because again, that cable is dragging against the inside of the conduit. So you start putting a lot of bends and things like that, you're cutting down that distance drastically. And again, we're going back to potentially damaging the cable. But with jetting, we can have the bends, we can have elevation changes, we can have a lot more change and call it, customize, being able to customize the route and still get the distance you need out of it. Again, setup time, you do have a little bit of an advantage with pulling, but again, the overall distance makes up for that. We talked about the footprint being a lot smaller, or excuse me, on the equipment, the footprint of the equipment is going to be a little bit bigger. But again, the cost savings, it just doesn't really matter, right? Less people, more efficient. There is a higher upfront cost with the equipment on the jetting machines. There's a lot of really great new technology out with the jetting equipment. So those machines can get pretty expensive, but again, when you're talking about being able to deploy five times as much cable, you're going to recoup that cost a lot quicker. So don't let the price tag on a piece of blown equipment deter you from looking into doing this. So here's a really neat picture of a test track, right? So this is how we kind of figure out how far can we blow the cable, right? What kind of, how does the fill ratio affect how far we can go? How far, how does the cable diameter affect it, right? If we do, let's say, test the limits on some of these things, how does that affect your attenuation? How does that affect the performance of the cable? So this is something that we've done with our cable specifically to kind of verify and say, okay, here's the best solution for what you are particularly looking for. Now, one really neat thing, this is definitely, it's not common at all in the US. I've personally only talked with a couple of companies that have done this, but doing jetting cable in an aerial application. This is, again, something definitely very new. So I wanted to include this in because I've had some recent conversations, actually, in particular with one customer that is looking at this solution because of some particular challenges they are dealing with. So we can do this a couple different ways. One, you can go with a multi-bank duct that has essentially, call it like a figure-8 cable, right? You have your duct bank, and then you have either a steel rope or a dielectric strength member, and it's like a figure-8 design, and it's self-supporting. So you can go that route. You string the duct bank up, and then you go through and you blow your cable through just like you would anywhere else. The other thing that you can do is, instead of having this, call it, what I like to call a figure-8 design, you can also lash your micro duct to a messenger, right? This obviously brings us down into the comm zone. But again, it's something to keep in mind. It's done a lot more in Europe. Again, right over there, they've been doing this a lot longer. And so they've got a lot more instances overseas of being able to do an aerial application. But yeah, again, right, depending on your situation, what you're trying to do, what you're trying to accomplish, this can potentially work. You are limited from a self-supporting standpoint of about 300-foot spans. So something to keep something to keep in mind, right? And also you need to look at, right, your load rating, the area that you're in, the weight of the duct, weight of the cable, in terms of make ready, things like that. So there's definitely a lot more that goes into it. But I wanted to include it just as something to kind of keep in the back of your mind if you ever do come across it. This is something we can help you out with. And I'm happy to introduce you to a company that's done a lot of this in Europe as well, can bring some really good knowledge on this topic. So some things to consider, right? If we're just trying to figure out what type of cable to deploy, right? If we're looking at aerial versus underground. Let's face it, at the end of the day, if you are an electric utility, ADSS is almost always going to be the way to go. It's almost always going to be more cost effective. It's certainly going to be more cost effective than going below ground. But there's still a lot of great reasons for going below ground. We have to look at our population density, potential growth, right? Again, planning for the future. Um, it's tough to anticipate how much you're going to need, but again, you want to be able to expand if you do need to, right? Whether it's increasing population, I mentioned 5G, right? Dark fiber, dark duct leasing. These are things you're going to need to take into effect. And I always try to tell people when we're looking at the cost of fiber and installing it, unfortunately, I see a lot of builds in rural broadband networks that deploy a lot of 24 count fiber cable. The cost difference in going from a 24 to 48 when you're looking at the grand scope of the project is very, very minimal. So yeah, it's you're better off kind of hedging your bet and going a little bit higher. Yeah, you may not need it for another 20, 30 years, but if something pops up and you do, you're gonna be really glad you opted for the higher fiber count, for the multi-duct bank again, just in case. Also, the type of enclosures. Some enclosures, some pedestals that are out there may work a lot better with blown fibers than the kind of maybe the traditional splice enclosure, maybe the traditional pedestal you've been buying. So I do implore anybody who's looking to deploy fiber network, right? Whether it's micro cable, ADSS, talk to those pesky sales guys that keep coming knocking on your door and calling your phone saying, "Hey, I've got a great new product." Go take a look at those guys, because a lot of times kind of what the standard bill of material might be that says, yeah, hey, we use this enclosure everywhere we work. There might be something out there that does work better, maybe something that your guys just prefer. So I do please recommend spend as much time as possible looking and seeing what all is out there. Um, so the last thing too, right? If we're in more of an urban setting, micro trenching could be a viable option. Again, it's something that's a technology that is growing in popularity. So when we say micro trenching, what we're doing is we're going to set is essentially going to be just in the roadway or just in a sidewalk. And so you can see the picture on your right here. This is a micro trench. So basically, think of a big concrete saw, if you will, concrete saw blade that's going to cut a couple inches wide, go down 12, 16 inches. And then what we're going to do is drop multiple micro ducts into it that are going to be stacked on top of each other. You drop that in. Now, you've got 3 or 4 ducts sitting in a trench that then gets covered with an epoxy. But now, instead of having to go tear up an entire road or bore, you've cut your micro trench, you've dropped your duct in there, and you're good to go. So again, definitely something that's starting to gain a lot more popularity in more highly populated urban areas. So let's look at the features of the cable itself, right? So again, micro cable, we're making it smaller. So if we look at a standard 288 fiber design on the left, this is non-armored, you're looking at 8/10 of an inch essentially. But in a micro cable, we're down to less than 4/10 of an inch. So we're dropping the size in half, right? So huge difference in the diameter of the cable itself. The other thing is too is as we're trying to get a defined stiffness out of our cable to be able to get it the maximum blowing length. So what we're going to do is use different types of outer jacket material, and we're going to shrink the size of our central strength member, and still trying to find that happy medium of flexibility but also strength. And then really at the end of the day, the cable itself just has a low mechanical characteristics, because again, we are just trying to make it as small as possible. Friction is going to be the big thing here when we're talking about how far we can jet cables. Again, right, we want to increase the hardness of the jacket to decrease the coefficient of friction, right? Because again, it's the contact between the pipe and the cable that's going to dictate how far we can go. So what we're going to do is use a couple different types of material in the jacketing. So most of your standard cables are going to use medium density polyethylene, MDPE. That's going to be basically your normal everyday armored cable, duct cable. But for jetted cables, we're going to use either HDPE, high density polyethylene, or we're going to use a polyamide or a PA jacketing is what you'll hear me refer it to. The next thing we want to look at is the diameter, right? So we want to talk about the fill ratio. Again, I mentioned this earlier. So that's going to be the ratio of the outer diameter of your cable to the inner diameter of your duct. So typically what you want to have is between a 70 to 80% fill ratio of cable to duct. 90% you can go up to that, but you really don't want to go too much higher, because if you go higher than 90%, what we're going to do is we're going to increase the touch points on the cable to the duct, which is going to increase friction, decrease the blow length. If we go too small, we're gonna decrease the amount of the pressure that we can get on the cable itself, which again it is also going to limit it. So if you can, right, kind of go between that 70 to 80% in terms of the fill ratio there, and then we'll continue talking about how we can help kind of find that sweet spot, especially if you've already got duct in the ground. So again, our options on the cable itself, we have our standard, you have a central tube design, and then we have what's going to most everybody's going to use is a multi-tube design, right? So from a just a picture standpoint, this is going to look just like many other outside plant cable that you're typically using. But again, you have the option of going 12 fibers per tube or 24 fibers per tube. So when we look at our multi-tube design with an HDPE jacket, it's going to come standard with a 250 micron fiber. This is what I'm going to call kind of the generic design, right? If you were to call up a cable company in the US and say, hey, I want a micro cable, 288, whatever the count is, you're probably going to get this essential setup, right? The HDPE jacket, 250 micron fiber. This is going to be kind of the standard or generic design that you will get back. Now, what we can do though is if we bring the PA jacketing into the mix, this gives us a little bit more from an option standpoint, right? So we can go with our PA jacketing with our 250 micron fiber. Essentially the same cable, just different jacketing. What we can then do though is we can drop down to a 200 micron fiber, and which is going to help us lower our diameter of the cable itself, right? Smaller fiber, smaller buffer tubes, smaller outer diameter. Then we can really, I guess, crank it down from a diameter standpoint and go to a reduced design where we have fewer buffer tubes wrapping around the central strength member. You do limit yourself from how many fibers we can get in. So again, right, it really just kind of depends on your situation, what you need done. The interesting thing, yes, I keep referring to, in Europe, how they do things and kind of how microcable design and jetting technology is a lot more common over there. So in the US, we tend to see more HDPE jacketing, but in Europe, the polyamide, your PA jacketing, that is what is going to be standard across the board over there. We are starting to slowly see a shift to customers trying the PA jacketing. But again, like any other kind of new technology, there's an adoption phase and kind of people figure out what works, what doesn't work. But personally, I would recommend going with the PA jacketing if you're looking at a micro cable deployment. Lastly, central tube design, right? So this is going to be a lot more what you're going to see with drop cables, right? We can get up to 24 fibers in the central tube design. But again, depending on what you're trying to do, you might see some of this deployed inside of large buildings, things like that. But again, right, depending on how you deploy your setup, you might have a certain setup where, let's say, maybe you have in a GPON design, you might have a centralized split architecture. You're using a splitter cabinet, and you might decide that you're going to jet a cable straight from your splitter cabinet to the home. So something like a central tube design here would give you obviously a smaller cable outer diameter to work with, which again is going to drop your cost. But from a cable prep standpoint, right, it's going to be a lot easier to get into this cable than a multi-tube design. So again, right, just a lot of different options and things to consider within your given fiber network. So when I talk about a lot of these different material types and things, what really are the design differences? So really what we're doing and the main differentiator here is going to be the HDPE jacket to the PA jacket. So the thing with polyamide is it's a much harder material. And so it's a lot, I wouldn't say stiffer, but it's just generally harder. So PA also has a lower coefficient of friction. But what I can do with that PA jacketing is I don't need to have as much jacketing there to still give the cable the protection that it needs with the HDPE. So the HDPE, I need to go a little bit thicker on the outer jacket. But again, right, the PA jacketing, it allows me to reduce the OD of the cable. But because of the hardness of the jacketing, I can jet it farther. So again, right, I mentioned the show that first, the HDPE with the 250 is kind of like your, call it generic design in the US. So that cable, is going to be anywhere between, call it, 0.2 inches to 0.44, right? But now I drop that down to the PA. We're dropping a couple hundredths off the outer diameter. But if I now combine that with a 200 micron fiber, now I'm really starting to drop down in the outer diameter, right? All the way down to that central loose tube design. So you can kind of see where that goes. And again, the thing with this is it's really just going to depend on what you're doing. Are you, is this a new build? You're picking the duct, you're picking the cable, or is it something where you already have duct in place, or you have a tight spot where you have to get that one micro duct through? That's going to be kind of maybe what dictates where you go in terms of what you pick. Right. And again, kind of just give you an idea of what the buffer tube, what switching from a 250 to 200 micron does, the buffer tube, 1.4 millimeter down to 1.2 millimeters of the buffer tube, which may not seem like a huge difference, and it's not. But if you're looking at a 288 fiber count cable, you put all those buffer tubes in the cable, and now we're dropping the overall diameter of that cable by over a millimeter. And again, right, saying it's a millimeter smaller, it sounds like, all right, what's the point? But again, it's all very much dependent on what your setup is and what you're trying to accomplish. The one thing though about going the 200 micron fiber, it is a little bit pricier. But again, the diameter is going to come down. So if you do have a strict diameter limit, that's when we'll typically bring in the 200 micron. But again, if you reached out to me and said, hey, I need a micro cable, it's going to come with the 250 micron. All right, so looking at the difference between the HDPE and the polyamide, the PA. HDPE is a little bit cheaper than the PA. So again, that's probably one reason I'd say why that is probably more popular in the US, just from a price standpoint. But again, the cost of the material itself in your project is not going to greatly impact the overall cost when you figure in labor. So there may be an instance where the longer that you can jet the PA, maybe it does save you some money here and there, but it is something to consider. Again, I think one thing that has put off some people on the PA jacketing is it is a harder jacket. It's a harder outer jacket. So if you've been dealing with medium density polyethylene, high density polyethylene, it's just something that it's different, right? But like anything else, just because it's different doesn't mean there's anything wrong with it. So you can see just the thickness of what we can do with the HDPE and the polyamide in terms of the millimeters, so we can drop a couple tenths of a millimeter off of just the thickness of the jacket. Rated design tension is going to be the same because, again, we're not pulling this cable. You really don't ever want to pull a micro cable. You only ever want to jet it. So again, right, if we're in a brand new build, we can dictate the duct that we're using, how many duct banks. We can dictate the inner diameter of the duct. Going with an HDPE could very much be the option for you. But again, you're going to get a little bit more friction. You're not going to be able to quite get as far on a single pass that you can with the polyamide. Lastly, 12 fibers, 24 fibers. Which do we go with? Really, it's going to depend on the amount of fibers in the cable. For blown cables, if you're going 24 fibers per tube, you are going to have less weight, smaller diameter. You are going to lower the price, but this is really more so on fiber counts of 144 and higher. When we go lower than that, you really don't see much from a cost saving standpoint. But again, a lot of this even just kind of comes down to personal preference. From a fiber to the home standpoint, I'm not a big fan of having 24 fibers per tube, because once you go into open up a tube, if you're only splicing, call it 3 or 4 fibers, or you're dropping off for a couple drops for a customer, the last thing you want is to have 18 extra fibers in that buffer tube and, have the potential to break something, break a fiber. It's just more stuff to get in the way. But again, at the end of the day, that really just kind of comes down to more preference than anything else. Now, can you blow or can you jet in a standard diameter cable? Yes. However, they're not going to go as far because of basically everything that we've talked about, right? They use an MDPE jacket, medium density, which is going to have a much higher coefficient of friction than HDPE. The jacketing is also going to be a lot thicker, which is going to reduce the flexibility in the cable itself. So if we have bends, we have, in the case of the picture on the right, you have a loop that you're trying to pass through, you're generating a ton of friction. So if you're going to jet cable into conduit, the micro duct and micro cable is going to always be a lot easier. Micro cables they are designed specifically for this type of application. And I use this picture on the right as an example, that this was a standard duct and a armored cable that somebody was trying to blow, and they were trying to jet this cable through multiple pedestals like this. And the complaint was, hey, this cable's not going very far. And so, yeah, of course, because it's an armored cable that's passing through duct. So that entire loop right there, all you're doing is you're getting the cable rubbing against that conduit. And so, in this case, unfortunately, had they known ahead of time that this is how they wanted to deploy it, they could have gone with a micro cable. They could have gone with a micro duct. They would have saved money on both the cable and the duct. But now, instead of only being able to get through maybe 3 pedestals like this, they could have potentially gotten through 10 or 15. So again, right, I think what they thought they were trying to accomplish could have worked really well, but unfortunately the product just didn't line up with what they were trying to do. And then on top of that, there's also stitch boring involved, which again just created more touch points of this cable, because again it is so much larger and so less flexible than a standard micro cable. Now, with that said, I do know somebody who is doing long haul routes with armored cable, and they're blowing it, but their directional boring, it is a very straight path. And they're having good success with it. But traditionally, in a design like this on the right, I could not stress hard enough. Just don't do it. It's just not going to work. So again, it's possible. Be very careful. And then really kind of the last thing is, look at with Blownin Cables, and it's really generally right, all underground builds. It's just going to clean up, right? Clean up the look of the neighborhood, right? So if you're up on the pole, you've got your power poles up there, you're in the comm zone, you might have 2 or 3 different internet service providers that are on the pole. So you've got just bundles and bundles of cable. But if I can move that below ground and get rid of the power, get rid of a lot of these extra cables in the air, it just looks cleaner. And I'm even starting to see a lot more towns go and actually put in call it a charter or laws in their town that everything has to be located below ground, really just to kind of get rid of the aerial clutter that you find. And again, just a few more pictures, kind of the differences of what you can do by moving everything below ground. All right, so that wraps up the presentation. Just really quick, I mentioned the PDH credit, the continuing education credits earlier. You'll get an email if you register for this. You'll get an email with a link to the quiz. You have 10 questions, must pass with a 70 or higher to get credits. It says the participation will be submitted within 1 business day. And then we'll also have a recording of this presentation uploaded onto our website on our Learning Hub. So if you have any questions, please let us know. You can reach out to marketing@ncabamerica.com for any questions. So with that said, I appreciate it again. Thanks for y'all's time. I'm going to open up my window here. If you guys have any questions, let me know. Let's see. All right, so got one question. What's the max blowing performance? 3,280 foot, one shot. How does it affect curves during blowing? And can we lease the microduct? So again, right? Yeah, kind of as touched on in terms of 3,280 foot in one shot. As long as the route isn't crazy, that can be done. I actually had a customer about a year ago had asked about jetting a 288 ADSS cable through standard duct. And yes, I had mentioned how the company that makes jetting machines, how a lot of times they can go and do calculations to give you an idea of how far it can go. So for this particular case, I reached out to somebody that I've worked with. They plugged in the information, and in that case, I want to say they said the ADSS could do, it was like 3,500 feet, 3,500 feet. So with a micro cable, that's 3,280 feet is going to be, easily doable, in my opinion. So yeah, again, right, it just depends on the route itself. And then in terms of leasing the duct, yeah, I mean, I'll just say that it's, that's going to be up to whoever owns the duct. Do you consider PA as the future of micro cables? I do, honestly. I think again, unfortunately, I think that the fiber market as a whole, the U.S. is very much behind the curve of kind of where the rest of the world is, and mainly Europe, right? We saw it with copper cables, right, going from Cat 2 to Cat 3, Cat 5. We were slow to adopt the new technology there. We were slow to adopt just fiber technology as a whole. And so again, right, micro cables are getting used pretty much standard over there. So yeah, I do think that you will start to see, more use of the PA jacketing. And again, I think just because of the benefits and the flexibility of what that type of solution provides, I do think essentially we'll get there. Yeah, again, like anything else, right? Something's different. You're gonna have the guys that are like, yeah, no, it's yeah, there's something wrong with this cable. It's harder. Yeah, the jacket's thinner. I don't like that. You'll get kind of those typical objections. But at the end of the day, the performance just, the performance can't be, you know, yeah, the performance is just there. So, wow. Well, so I guess my familiarity on the topic, I guess, had me breeze through that presentation a lot longer than or a lot quicker than I did last time. So yeah, we've still got 15 minutes. If you guys have questions, feel free. I'll we'll hang around here for a few more minutes. I guess for those of you on East Coast, you still got some time on your lunch break to go grab a sandwich or something. All right. Well, again, if you guys have any questions, yeah, feel free, email us. You can email myself as well. My email is tim.buffkin at incapamerica.com. Or you can reach out to marketing as well, marketing at incapamerica.com. So again, thanks for your time today. Appreciate you taking some time out of your Thursday. And yeah, I hope this was beneficial to everybody. Again, thank you.